In my last video, I was trying to build a game in which aliens could have a variety of recovery behaviors. In researching how to do that in Rust, I ran into this Stack Overflow post, which showed a number of ways to store a code snippet in a struct. I used the function pointers version, but it seemed to me like I'd learn a lot if I could decode the rest of these options and rebuild my recovery code using each one. For this video, I started at the top with what he called unboxed closures. Full disclosure, I have a whole video of me trying to use this strategy, but I missed some very important points, and I don't want that video to lead anyone astray. Instead, I'm going to explain the example and then show how that would work for my situation. This is his struct. He's storing the code in the field named foo. The type on foo is the generic, which is defined as Fn mapping usize to usize. Fn is a trait, and that type of closure means that you can be called any number of times, and that's because one of these three things is true. If it captures something, it doesn't move it out of its body, and it doesn't mutate it, or it doesn't capture anything. In the implementation of that struct, he builds a new method, which just stores the closure parameter into that field. In his main, he uses foo.foo to add 1 to a parameter. So both of these will evaluate to 42. This was really hard for me to parse because everything is named foo. To try to clarify, the one that is capitalized, which I've marked with a red rectangle, is the type. 1 is a local variable, which I've marked with a green rectangle. And then the ones with the purple rectangles are referencing the field within the struct. That's what I understand after studying this code. However, when I first mimicked this code, I just recreated the function pointers implementation with a lot of extra complexity. And that's because there's a subtlety in this example that I, as a newbie, didn't see. This is a great example of the fact that learning something new often requires an actual human to help you out. When I got stuck, I got help from Bowman7593, and he emailed some great explanations and examples to help me see what I missed. I've linked his GitLab in the description so you can see the fun stuff he's building. In this main, the example is really just passing in function pointers because he never captures anything. The compiler makes those snippets into function pointers, and function pointers implement the Fn trait so they can work here. When I tried to modify my mimicked code to capture something, everything went awry. So let's start by modifying his example to be able to capture something so that I can show you some of the other things that Lucas taught me about closures. So this is that original code. The only thing I've done is made it print out what these things evaluate to, and you can see that I get 43 and 43, which is just what we'd expect. So in order to capture something, let's suppose that we want to have a count that is used to control what goes on, so we know how many times something was called. So this is going to be a mutable integer, and I'm going to start it at 42. Oh, everything shouldn't be 42. I'll start it at 12. And then what I want this closure to do is to decrement the count because somebody called it. So I would say count equals count minus 1, and then do what the closure was going to do anyway, a plus 1. And it's mad now because this is changing something that it captured. So it's mutating something that it captured, so we can't use Fn as the trait. Instead, we have to use FnMut to admit that we're going to make the changes. And there's like a subtle reason why you have to do this. But it will help if we had multiple threads doing things. It will help Rust keep everything safe for us. So I had to make it FnMut up here. And that means that I also have to make foo be mutable as well. And this works. Let's print out what happens to count when we use it. Count is now 11. So count got decremented. Now, that's a really important point. When we let this closure capture count, it captured a reference to this count, which is what you'd want to do if something in your main also cared about what that count was. If you wanted to pass in a count that was just supposed to limit how many times foo was going to do something, like it was going to check to see if that count got to 0, you could say move. I think it's move. No. There. Okay, so now that has told the compiler when you capture things, move them into this. So essentially you're going to put your own one over there, and the one that is still, that we declared here is not going to change. So if I run that, the count outside stays the same. So that was one important thing. When you are making a closure, you can choose when it's capturing something. Does it capture the one that's out there, or does it get its own copy of it that it captured? The second thing that we need to pay attention to here is, why is this generic? Like, you do it this way because the example says to do it this way, but it has to be this way. And the reason is, suppose I tried to debug print this. Because I don't understand it, and that's why. If I understood the details of what that hashtag was doing, it wouldn't be so hard to remember. If I say derive debug of this, and then I try to use that, it's going to be mad at me. And the error in this is going to explain something to us, for us. So this says closure, yada, 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 main line numbers doesn't implement debug. That's a really important thing. The type of the thing we're passing into foo, the type of this, is unique to that closure. So even if I went down here and I made this one do exactly the same thing, and instead of printing it, I try to debug it so that I get the same kind of error message. That must not be right. Let's just do it again the way. I don't like embedding all that code in there anyway. Two. Now, if we look at the error message for this one, the closure is line number 24, character number 31 to 2440. That is the name of the type, where in this one, the name of the type is a different one. So even though the closures look exactly alike, and they have the same parameters and the same return type, every closure gets its own type. And the reason that they do that is because even if the parameter and the return value are the same, the closure might be a different size because it captures different things from its environment. So every single closure has its own type. the effect of that is I can't put a single type here that every closure, like I can't put like this there because they're not all the same type. They implement that trait, but they aren't all the same type. So that's why I have to, if I'm going to put an unboxed closure in a struct, I have to make that struct have a generic that's going to be the type for the particular closure that I pass into when I create that struct. So this example taught me a couple of things. It taught me that I needed to use, that in order for these to really be closures, I need to capture something from the environment. When I capture something from the environment, if I change it, I need to use FnMut instead of Fn. And I learned the magic of move versus don't move. Oh, actually, that's a really interesting thing. If I do this, print out down here, and I have not moved either one of these, count. Why is that mad? Cannot borrow count as immutable because it's borrowed as mutable. I did that just a minute ago. Well, and now we know it's just confused because this all better. Sorry, I confused myself. When I said not move, that put it into there, and then it gives it back to us, and then we put it into there again, I think. Anyway, if I do this, count got decremented both times. I wonder, can I print out count between these two things? I'm curious who owns count at this moment. No, I cannot. So while since I didn't say move, I gave this ownership of count until it finished, and then it gave it back, but it isn't finished with it until after I call it. So that's why I can't touch count in between these. Does that mean I can't do this again? Oh, do the whole thing, dude. Moron. Yeah. Okay, so there's an interesting ownership thing that's going on there because I did not do move. So each one of the closures did not get their own count. Then this one owns count until I'm finished playing with it. So this one can't have it in the middle. This is how they're preventing erase conditions on those things. Once some dude owns it, some dude owns it. And you can't give it to some other dude to own it because two people can't own it. That's pretty slick. But when I don't do this, the compiler knows that this foo is never called again after this moment. So it goes out of scope. And the ownership of count goes back to my main. So then my main can choose to give it to the second one and it can use it. That's pretty slick. Okay, so I think at this point that lets me understand this example. So now I think I could try to take my function pointers version of my alien recovery and make it use this way where I can actually use an actual closure instead of using function pointers. So this is the code I'm going to start with. This is the function pointer version that I built in the last video. I want to change this to use closures, unboxed closures, like we just played with. One thing that I really didn't like about this function pointer version is that you were giving it the whole alien that it could play with, and that seems really insecure. So I'm going to start by making a struct that is the recoverable attributes. And I'm going to put these two fields because those are the things that I think should be able to be recovered. And then this is going to have recoverable attributes that are recoverable. And so this, I'm going to have to figure out, this should be recoverable, giving it I'm not going to need these function pointers, these functions anymore. Okay, and I'm going to leave my main alone for a minute because now that I've done that, what I want is I don't want this to be this. I want this to be the recovery behavior. And so I need F. Okay, so now I have redefined my struct to be generic over closures. I've pulled out the things that recovery behaviors are allowed to play with, and I've made the closure have that as a parameter. And so my recovery behavior is going to be an F. I have to put this same generic on here so it knows about it too. Oh, I have the syntax of that backwards. Why does it think? Oh, because I made it. Recover is just going to call that. It can do whatever it wants to do to itself. And it has to pass into itself the things that are recoverable. Which means I have to mark them here as mutable. Oh, that's not how I do that. Recoverable is a mutable one of those. No. Oh, that's where I have to say it's mutable. And okay, so this is going to be a method where I can say for an alien, recover. And it's going to call its recovery behavior passing in a borrowed mutable recoverable. Okay, I like all of that. And so the point of I've made this separate thing, if I wanted my game to say some alien's armor is recoverable, I could put armor points in there. But things like its location, where it is on the map, is not recoverable. So I wouldn't want the recovery behaviors to be able to play with where is it on the map. So I like that I have separated what is recoverable from what is not. So, you know, if I had map X, this would be a crappy way to do this, but you know, if it's X location was a use size and its Y location was a use size, which would be gross, but you know, if it was, then people who are making these recovery behaviors, if somebody else is building stuff, then they would not be able to play with my position on the map. They'd only be able to play with the things that are recoverable, because that's what gets passed into the closure that they make. So they don't have, those closures wouldn't have visibility to these other attributes of an alien. So I think that's very nice. I could have done that with the function pointers, but I was not aware enough of Rust capabilities to be able to do that. So I think that's just a general improvement. So if I have now declared alien like this, my main that's supposed to deal with all of this is not going to be very good. So let's just say Fred just gets 5 points back. Every time we tell him to recover, he gets 5 points back. Then what I would pass in is I would pass in its recoverable attributes, and I would just say a.life points equals a.life points plus 5. Why can I not? Oh, so I can't debug print Fred anymore because this particular closure that I've developed right here doesn't implement debug. Lucas was very nice, and he gave me some code to show me how to implement debug for when there are things that you can't have. And so this is going to be recoverable attributes. And I need to use some of the standard things in order to build this. Actually, I wonder if I can do because I implemented debug for that. So his point here is recovery behavior. We're just going to say the word closure because we just know it's a closure. We don't know anything about what's inside of it. So now, because I have implemented debug for alien F, where F is a mutable FnMut, recoverable, yada, 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 now I can print the debug version of him. Okay, so now all of Fred works. If I wanted Mighty Max to recover everything, instead of this implementation, I would say he gets to get his initial life points back. Okay, so I think this should do exactly what the function pointers one does. And if I run this, we can see Fred starts out with 100 life points. So he starts out just the way he's supposed to. I whack him and he goes down to 50. I tell him to recover. He goes up to 55. Perfect. Mighty Max, I whack him. I tell him to recover. It goes back to 100. But okay, this still could have been function points because neither of these pieces of code is capturing anything. So let's say that Mighty Max, when he recovers, and I will again thank Lucas for this example. When Mighty Max recovers, he starts out, he recovers 5, and then the next time he can only recover 4, and then the next time he can only recover 3, so on and so forth. So I'm going to create and for Mighty Max, I'm going to say his life points. Oh, I'm going to have to put this in curly brackets because I'm going to need 2 of them. His life points is going to be his life points plus recovery strength. And then I'm going to subtract from his recovery strength. Why does it not like that? Oh, because it is immutable, but I need to make it mutable. And so when I make him recover once, he should recover 5. If I made him do it again, he should recover 4. And so, yeah, so he recovered 5 there, and then he recovered 4. And this is where that slick move thing it is. Like, I did not move this in here. So I can add to these recovery strength. Because I did not move it in there, oh, think about this. I did not say move. So I thought that meant I could look at it. Well, let's just do that on the last one. And see, but let's just do it here. Okay, so this has borrowed it as has mutably borrowed it. And so I need to, like, we need to be past the last time Mighty Max is ever going to use it to get it back. I'm a little surprised that I can't get it in this, but I think I need, oh, that's what it is. I need Mighty Max to go completely out of scope so it gets dropped so that it no longer has that mutable borrowed version of it. And then I can print it out. So we can see this time I have told Max to recover twice. So recovery strength should have gone down because I did not move it. Yes, and you can see recovery strength has gone down to 3 after that. If I had said, oh, and where did I put the move? There's where I put the move. If I put the move there, then I could also be printing out recovery strength all of these times, I believe. Yeah, so I can always see mine, because I've given him his own. So I own one, my main owns one, and Mighty Max own one. And when I print out mine, mine no longer goes down. I would like to do that in a way that I could still peek at what the value is. So I don't know how to like share the value. Okay, so I'm gonna have to ponder this part, because what's happening here is the owner of recovery strength is that closure. And if I wanted my main to be able to see how much of it he has used up, I don't know how to get a reference so that I can still peek at that. But that's like a totally different problem than the problem that I originally started with. I now have, let's go all the way back to, I now have passed in this, because it captures recovery strength from the environment. This has to be a closure. It can't be a function pointer. And in order for me to be able to do that, I had to change alien now has to have a generic, because every closure is its own type. So I can't specify a particular type there. FnMut is a trait, not a type. And so that's why I need this to be a generic. I can save that. I can call it. I can make it all work. The only thing that I can't do is I can't peek at if I have not given him his own copy. I still can't look at my copy until he goes out of scope, because I have given him a mutable reference to it. And that mutable reference means that he owns it while that mutable reference is there. And then when he goes out of scope, I can look to see what has happened. But while he's alive, I can't figure out how to look inside. I think that gets at the main point of this. Now, the weakness of unboxed closures is if I say let aliens equal thread and Mighty Max. So like I want to put them together, and I want to have a list of all the aliens so that I can walk around and tell each one of them to recover every tick of the clock. I can't do that because, and this looks like this error is very silly. It's a type mismatch, but they look exactly the same. The reason is, well, and actually, okay, it made Fred be a function, not a closure. So let's give Fred something to capture. Oh, curly brackets. Make them all be a thing. Semicolon. Curly brackets. Okay, so now Fred has to be a closure too. And now if we look at this error message, it looks like I found the same thing on both things. What is possibly wrong here? And the reason is because every closure gets its own type. So Fred and Mighty Max aren't of the same type, and therefore I can't put them together in a list. And that's going to be the motivation for boxing them, so that I can make something that goes all through them. And the next thing in that Stack Overflow is boxed. I hope that was interesting, and I hope that you'll come back to see the next one where I'll do those boxed trait objects.